Welcome to my implicit differentiation videos. This is going to be one where I did videos on implicit differentiation, now I'm doing them with a graph so you can sort of understand a bit better. Before it was just techniques and how to do it. Here I'm showing you with the graph so you can start thinking about things from a different perspective. Anyway, so I have example 1. It's going to be, you have a y direction, you have x. Keep in mind that y is a function of x. And it's going to look like this. Okay, so think about it. It's not going to pass the vertical line test because if you put it at this point, it hits the y, it hits 3 different y values on one x value. So you do implicit differentiation, and the function is x to the power of 3 plus y to the power of 3 equals 6xy. I actually do most of my videos, and I got the questions in this for this series in this book. It's called the Folium of Discar. I think that's what it is. But that's basically what it is. And it says that you can either do each bit separately, so when you do the vertical line test, it only hits a y value once, or you can do implicit differentiation and do it the whole time. By the way, this book is James Stewart Calculus. Copyright is, if it can focus, Sengage Learning or something like that. Yeah, I'll put it in the description, but this is the book that I use for basically all my calculus. So, anyway, let's get right onto the math. So, like always, we do the derivative of each side. Okay, now, for this side, we're going to need the product rule because we've got a function times a function. And because we've got a 6 kicking around, what I'm going to do is I'm going to connect the 6 and the x together and multiply that onto the y. So we'll call this one the 6x u, and we'll call the y v. If you wanted to, you could call it u as x and v as 6y. It doesn't matter, but in this case, I'm doing u as 6x and v as y. Anyway, so the derivative of x to the power of 3, 3x to the power of 2, chain rule, and then you find the derivative of the inside, which is just derivative of x with respect to x, plus 3y squared, and then you do the derivative of the inside, which should be derivative of y with respect to x. And then over this side I'm going to need u dash v plus u v dash, because it's the product rule. Okay. So if we neaten this up this side a little bit, all we'll do is just have 3x squared plus 3y squared multiplied by dy dx equals u dash 6 derivative of 6x. First, the derivative of 6x is just 6. Then you multiply by the derivative of the inside, which should just be dx on dx, multiplied by v, which is just y, plus u, which is 6x, multiplied by the derivative of y, which is just the derivative of y. Okay, now we'll continue on. So we have 3x squared plus 3y squared multiplied by dy dx equals, this will just be 6y, because 6 times 1 times y, plus 6x multiplied by dy dx Okay, now I'm going to put all the dy dx multiples on one side and all the others on the other to keep them separated. So I'm going to keep the 3x squared on this side, subtract both sides by 6y, so 6y will move onto this side, negative, become a negative, and I'll keep 6x multiplied by dy dx on this side, and I'll subtract both sides by 3y squared multiplied by dy dx. That way it'll come on this side as a negative. Okay. Now we're going to have to, this will stay the same. This will I'll factor out the dy dx from both of these to isolate the derivative. That way we'll have 6x minus 3y squared. And then I'm going to divide both sides by 6x minus 3y squared, which will cancel it on this side. And dy dx will be on its own. And I'll have 3x squared minus 6y divided by 6x minus 3y squared. Okay, and that there is what, if you have the y and the x values, you can find the slope at any point on this. Okay, now I'll do one more example because these are a bit quicker. Example 2. We have a graph that looks like a square, but basically all the corners, that was poorly drawn, all the corners are rounded. And the function for that is x to the power of 4 plus y to the power of 4 minus 16. And it's also in this book that I showed before. Okay, so this one's pretty easy. We're just going to find the derivative of both sides, like usual. Okay, this side's going to be 0 straight up. This side, x to the power of 4 derivative is 4x to the power of 3 multiplied by the derivative of the inside, which is just dx with respect to dx, plus derivative of y to the power of 4 is 4y to the power of 3, because you take 1 off the power, and then you multiply by dy dx, because that is the derivative on the inside. Now what we're going to do is subtract 4 from either side, 4x to the power of 3, because this is 1, so we won't need to worry about that. So then we'll be left with 4y to the power of 3 multiplied by dy dx equals negative 4x to the power of 3. And to isolate dy dx on its own, we have negative 4x to the power of 3 over 4y to the power of 3, because we're going to divide by both sides, which will cancel this out and bring it over to this side on the bottom. And we can cancel out the 4's, and we'll be left with a negative fraction, x to the power of 3 on y to the power of 3. And that there, if you have these two coordinates, if you have an x and a y coordinate, or yeah, just positions, you can find the slope at any point. Alright, thanks for watching, I hope you learned something, and I hope you have a good day.